What is up everyone? In this video we are going to discuss about this problem which says that we have to reverse a stack using recursion. Okay, another way to say this is that we have to reverse a stack using another stack. Because if we know about recursion is nothing but using the function call stack. Okay, so what is function call stack? Suppose we have a code, right, in which we have a certain function x that we call. Now when we have the definition of x and we perform all the operations and then we return back to code, how do we return back to code, right? And how do our program remember all the variables that were defined here so we can use them here? This all is remembered using a function called stacks that every program has. Okay, whenever we are calling any function from a parent function, whenever we are calling a child function from a parent function, the information is stored in the function called stack. Okay, so it helps us to resume from the point where we paused this particular function. So this was something about the function call stack. And if you are using recursion, basically we are going to use the function call stack to remember all the values. Now let's come to the problem. The problem that we have is, suppose we have some elements 1 2 3 4 and 5. Okay, we have these number of elements in the stack. Now if you're talking about stack, we know that it is a LIFO structure. Okay, so whatever goes in last comes out first. Okay, so if we have to pop from this stack, we will get 5 first, then we get 4, then we get 3, then we get 2, and then we get 1. All right, so how do we approach this problem? We have to reverse it, right? So our approach should be like, we pop out all the elements, right? We pop out all the elements, and then we have to insert it in such a way that this 5 goes in first. All right, so this 5 goes in first, then we have 4, then 3, then 2, and then 1. Okay, so this is the approach. This is how our program should be performing. Now to pop these elements, what we will do, we will use recursion. We can definitely use recursion. We can write a program something like this, suppose we have a function reverse, right? Reverse, and we have stack int st, right? So when we are to pop the elements, what we will do, we will just simply say int top is equals to st dot pop. So it will store this first element 5, and then we can call the reverse function with the same stack, and we can call it by reference. And after that, what we will do, we will push the same element back, right? Now this program is not correct. Why do I say that? Because first thing, we will have the base condition where if our stack is empty, then we return. We will discuss about that. That is not the issue here. What I'm trying to get at is, suppose this is the stack that we were discussing, right? 1 2 3 4 and 5. Now suppose the first thing, we call this we call this for the first time. What happens that tp will store 5. Okay, okay, let's to make it simplify, let's have the top element here. So when we are calling stack, calling this function when stack has 5 at the top, what will happen, that tp will have 5. Okay, then it will call reverse for 4, right? So again tp will have 4, and it will call reverse for 3. Then again tp will have 3, then it will call reverse for 2, and so on. But when we are returning back, what will happen is the element, okay, let's complete it, then only it will make sense. We have reverse for reverse 1 we call, and then we have tp as 1, and it will call for reverse null. Null is something I just used to specify that it is empty. It not necessary had to be null. Okay, so currently our program is here. Okay, and here we have the condition, if empty, then return. Simple. So if we return from here and we push the top element, the return function will return control to this call, right? When we have top as 1. So what we will do here is we are just we are just pushing all the elements back at the same order that they were taken out. Okay, so it is not doing the work for us. So the approach that we have to use here is, instead of using this push function, we have to use a function. We have to use a user defined function here that will insert at bottom. So what this particular function will do is, suppose we are talking about this. Suppose we are just 1 second. Yeah, suppose we are talking about this case. Okay, so we are at reverse 3. So for reverse 3, what will happen? We will have elements like 2 and we will have 1. Okay, so for reverse 3, what will happen? Insert at bottom, this function will take out all the elements from the stack. First it will take out 1, then it will take out 2, then it will insert, then it will push 3 on the stack. Okay, it will push 3 on the stack, then it will it will return the control back to its parent, which will push 2 on the stack, and it will return call to its parent, which will push 1 to the stack. So this is how we are going to approach. Okay, so let's enough about the theory thing. Let's write the real algo. Okay, so what the first thing that we will do is we will use the function called stack to store each element, right? Recursively we will call for reverse with 1 less element, and at last insert the elements back using insert at bottom function. Okay, so let's write the code for this. Okay, so to write the code, we will have, first thing that we will write is void reverse. We will call it by reference, so we don't have to return anything. Okay, so the first thing that we will do is we will have the base condition if st dot empty. If it is true, if stack is empty, we will simply just return, right? Now since we have returned here, then anyway, if we are in this if condition, we won't be executing afterwards, so we don't have to exactly write the else statement here, right? So we will have int tp as we will have the element as st dot pop, right? Then what we will do, we will recursively call. We have popped the first element, right? And since it is by reference, then we are performing operation on the original stack, okay, not on the copy. We will recursively call reverse again, and then at the end we will do insert at bottom. We will pass a stack and the element that we have to insert, and that's it. This is the function. Now since this insert at bottom is a user defined function, we will have to write code for this as well. We have void insert at bottom, and we have here stack int called by reference, and then we have int element, right? So the first thing that we will once again check key, okay, we will write base condition later. Okay, first thing we will have, if stack is not empty, if stack dot empty is equals to false. Okay, in this condition what we will do, we will like we discussed here, we will take out all the elements one by one, right? So we will once again have the same thing. We will have int TP. Basically we are doing this exact thing once again. So we will have TP as st dot pop, okay, st dot pop, and then once again we will recursively call insert at bottom, right? And we will pass stack and the element that we have to insert, and then we will simply, like we discussed here, we will simply push back the element that we have popped out. So we will do st dot push our top element. Okay, so this is something that we will do when our stack is not empty. Now what if our stack is empty? If our stack is empty, that means we have reached the bottom, and when we are at the bottom, what we do, we push the element that we have. So else what we do, we st dot push the element, and this is the code. This is the entire code, right? So we will, write it with okay, so this is the entire code for this problem. You can try it yourself. You must try it yourself. Now I'm going to make another video in which we are going to discuss about how can we sort our stack using recursion, which is a natural extension of this particular problem. All right, so see you in next.